Hello everybody, today I will be showing how to prove that this f of x 5x minus 3 is continuous at x is equal to 0, x is equal to minus 3 and x is equal to 5. Now this is the question of first exercise of continuity and differentiability of class 12. So let's prove it. So to prove the continuity we know that we have to prove f of that thing. Suppose that constant is c, f of c is equal to limitation of x tends to c f of x. If this becomes equal, then we have proven that the given f of x is continuous at any point. So first take the first one, like x is equal to 0. So at x is equal to 0, f of c, what would be f of 0? By putting 0 in this 5x minus 3, we would get 0 minus 3, that is minus 3. Okay, now limitation of x tends to 0, x tends to c, so c is 0, x tends to 0, f of x, that is 5x minus 3. Okay, now this can be written as limitation, this can be written as a limitation of x tends to 0, 5 of x minus limitation of x tends to 0, 3. So this whole thing will become 3 only, because there is no term for the x so that it can be turned to 0. So that's why this whole term would be turned to 3 only. So it would become limitation of 5x, 5x would be 5. Okay, minus, this limitation of 5x would turn out to be 0, and this 3 would be like, and this minus sign would be the same, minus 3, that would become minus 3. So we see that the f of c is equal to a limitation of x tends to c, thus these two are equal, thus continuous. Okay, now same thing we will do for x is equal to minus 3. For x is equal to minus 3, we will get f of c, as minus 15 minus 3, that is minus 18. Okay, now limitation of x tends to minus 3, x tends to minus 3, 5x minus 3. Okay, now this can be written as limitation of x tends to minus 3, 5 of x minus limitation of x tends to minus 3, 3. So this whole thing will again become only 3. So we would just be getting 5x. This would be minus 15 minus 3, that is minus 18. So here also we can see the both are equal. That's why at x is equal to minus 3, it is continuous. Now let's see the last situation, which they have mentioned as x is equal to 5, last point. So at x is equal to 5, f of 5, what would be getting? 5 has a 25 minus 3, that would be 22. Okay, now limitation of x tends to 5, 5x minus 3 can be written as limitation of x tends to 5, 5 of x minus limitation of x tends to 5, 3. Now in this term will again only become 3, because there is no term for the x, so that we can substitute with it y. That's why now this whole term would become 5 into 5 minus simply 3, because there is no term for the x, so that we can put the value of the x as 5. That's why this would become again 25 minus 3, that is 22. Again we see that it's equal. That's why at x is equal to 5, f of x is continuous. So in all the three situations we have proven. So the first question of the first exercise of the continuity and differentiability we have completed. Thank you.